Welcome to the NetVault Server Backup Case Archive presentation. During this presentation we'll talk about archiving concepts and we'll do a demonstration of the application. While the NetVault Server Backup software has many capabilities, we're going to use it for archiving purposes. If you're familiar with a production environment, you may have heard the terms nightly backup or weekly backup, incremental or differential backup. These are backups that are performed by the system automatically either each night, each evening, or maybe once a month. Archiving is meant to address the evidence retention requirements of long-term storage of casework and evidence. Another benefit of archiving is it can free up space on your online storage, typically RAID arrays. The archiving concepts that we're going to discuss are the life of a case, the life of a tape, the concept of one case, one tape, and tape groups, which is how tapes are allocated to specific jobs. For the demonstration, we'll talk about the NetVault GUI interface. We'll create and discuss a demonstration case. We'll create, schedule, and run a case archive job for that case. And then we'll create and run a restoration job. The following demonstration is very basic in nature. The main goal of this process is to allow you to archive your casework and evidence to a tape for long-term storage. The software has some very sophisticated features, but we're going to start with a very basic approach. Remember, our goal is to take a case and write it to a tape or tapes. Let's talk about the life of a case. When you create a case, we recommend that you create a backup job for that case at the same time. Once you acquire the evidence, you can run that backup job to preserve that evidence. Typically, the evidence represents the majority of the case from a storage perspective. Once we've acquired all the evidence, we can calculate how many tapes will be required. Once the tapes are allocated to the job, we can run that job to preserve the evidence. As we work the case, we can rerun that job, overwriting those tapes, again to preserve the work that we've done. Finally, when our investigation is completed, we can run that job a final time. This is our case archive. Let's talk about the life of a tape. When a brand new tape is inserted into the loader, the software detects that tape, tries to identify it, and if it's brand new, it blanks it or formats it. In order to allocate tapes, we need to assign them to a group. This is done during the labeling process. We recommend that you create a group that matches the job name exactly. This is how we allocate those tapes to a job. When the job is run, the tapes in that group are only available to that job. When the investigation is complete, the job is run for a final time. That tape or those tapes are then removed from the loader and sent to long-term evidence storage. Here I've created a sample case. I'm calling it Case 1. It's a collection of uncompressible large files which simulates the information you'd gain from acquiring data. Notice that the case is located on my V drive on my external RAID array. The case itself consists of 31 gig of data, so it's pretty small, but it'll do great for our purposes. Notice I can tell the size of the case by looking at the case properties. Obviously 31 gig will fit easily on a single tape. However, sometimes more tapes will be required. Let's create a backup job for our new case. Create backup job. Let's call it Case 1. Let's go into selections. So selections is basically what we want to back up. We use the add new. Now, when we created our case, we created it on our V drive, but this was from our workstation, right? The server itself has no idea what a V drive is. We have to figure out where the external RAIDs are connected to the Linux file system. Here's the Linux file system. The RAIDs are connected under MNT. XRAIDs. XRAID 1, this is looking familiar. Here's our case 1. Right. I'm going to name this case 1 as well. A backup job consists of a number of other sets. The selection set, which we've just covered, talks about the files that will be backed up. There are plugin options, a schedule, target storage, and advanced options. Some of these sets I've established defaults for so that it's easy to set up a job. These defaults won't typically change. For example, the plugin options has an underscore default, which I've created. The advanced options also has an underscore default. Now we're left with essentially scheduling the job and allocating the tapes. We'll skip over scheduling and we'll look at tape allocation. I'm going to create a new target storage. Instead of a default, I've established a clone. Clone has most of the settings already selected properly. Once we've cloned the underscore clone, we can change the important stuff. The media in group has to match the case name. This is the allocation method. In other words, when this job runs, it will only select media that's in a group, case 1. The only other thing we have to do is save this. Alright, now we've set up our job. We've selected the selections. Right, there's our case 1. We've selected the target storage. The only other thing we haven't done is selected the scheduling. Right now this is scheduled to run immediately. If we were to save and submit the job would run right away. Of course, there'd be a problem, right? We haven't allocated any tapes to this job yet. In other words, we haven't labeled any tapes into the group case 1. If I save the job is saved, but it is not submitted to the scheduler. So let's allocate a tape to the case 1 group. Manage devices. And here we have a blank tape. Properties. If I drop down media label, the default is the barcode, which is a good label. In the group label, this is where we're going to put in case 1. These other fields are not necessary to update. At this point, the software is going to take the tape from slot 4 and mount it into the tape drive itself. The drive is going to read the tape to make sure it is indeed blank, and then write a magnetic label similar to a format operation to the very beginning of the tape. You can note the operations that are occurring on the tape. It's put the label on there, and you can see that case 1 is the group for the tape. If we needed more tapes for this job, we would simply label another tape into the case 1 group. The operation is completed, and now the loader is moving the tape from the drive itself back to slot number 4. Now we're all set. Now that we have a tape or tapes allocated to the job by labeling them into, in this case, the case 1 group, we can schedule the job. Scheduling options are daily, or once a week, or immediately, or just one time and one time only. One time and one time only is typically how we're going to run a job. In other words, we're going to typically schedule a job to run that evening at a certain time, one time, and then not run again until we tell it to. Be careful though, because these options are maybe common to other jobs. So if you change the once definition here, other jobs that are scheduled will also change. Therefore, if you need to run more than one job at a particular one time, you can create a once or a once-A or a once-B, etc. Let's take a look at once. You can see it's scheduled to run once at 1700, which is 5 o'clock local time. Note that it's scheduled, this job was scheduled previously, or a job was scheduled to run once previously, so we have to make sure to update the date. So on a specified date. So now it's set to run once, one time, tonight, 1500. Save and submit now sends this to the scheduler. Looking at the job status, you can see that the case 1 job is now scheduled to run this evening at 1700. Notice that the backup complete and last status are showing information. However, that is because this job was created and run previously by me as I was preparing for this. Even though the job is scheduled to run this evening in a few hours, we can run it now just for demonstration purposes. The job monitor screen is very handy for checking up on the job and seeing what it's doing. At this point right now, it's actually allocated the tape and requested that the media be loaded from slot 4 to the drive itself. Because it's a very small amount of data, this backup job will go quite quickly. You can see here the transfer rate and the amount of data moved. The job's still running, and you can see it's settled down at almost 300 megabytes per second, which is pretty quick, almost as fast as copying files to rotational media. Now the job is completed. You'll notice that the catalog job is now running. The catalog is the internal database that the NetVault software uses to keep track of jobs and tape contents. I've set it up so that after each job is run, the catalog job is automatically run. This keeps the catalog up to date in the event that the catalog database became corrupted and we needed to restore it from tape. You can see from the server monitor that the backup job waits until the catalog job is completed before the entire job is complete. Note that there's still a job scheduled. When you run a job immediately, it's removed from the schedule, but if you run now on a job which is scheduled, like this one was, it remains on the schedule and would run again at its scheduled time. So we can go in to the job and remove the schedule here. There we go. So let's assume that the job has run the night before, and let's take a look at the reporting. The two reports that are of most interest to determine how the nightly jobs went are the historic jobs by date and the single job summary. I usually set this to 1 day. You can see I've actually run this job a couple of times, but the last time we ran it, the important pieces of information are the job ID, which is 71, the instance, which is 3, and the selection tree, which tells us what files were included in the backup. Here you can see that the case 1 folder was included on this backup. The single job summary requires the information from the previous job, meaning the job ID, which was 71, and the instance, which was 3. This information indicates the job itself, when it was run, how much data was backed up, as well as the barcode of the tape or tapes that were used for the backup job. I might recommend that you export this to a PDF file and save it somewhere on your system, or print it out and include it in your hard copies to document your backups. If this was the final or archive backup job for this case, we should take this tape and eject it out of the loader itself and put it into long-term storage. To do that, the first thing we need to do is we need to export this tape. This sends the tape from the current slot, which is slot 4, to the mail slot, or the export port. If there were more than one tapes, or if you wanted to remove quite a few tapes, it would be much more efficient to eject the entire magazine. Now that the tape is in the export or mail slot, we need to unlock the mail slot with the software. Open Door opens or unlocks the entire loader and allows you to eject either magazine. Open Entry and Exit allows you to just open the mail slot. At this point, the loader is unlocked and you can physically manipulate the front panel of the loader to open the mail slot, remove the tape, and it would be a great opportunity to put a new tape with a label on it into the mail slot. Here's a view of the front of the loader. I've selected Main Menu, Commands, and Open Mail Slot. Hitting Enter here unlocks the mail slot and you can remove the tape. Let's say some time has passed and we need to restore this case from our long-term archive. First thing we need to do is set up the restore job. Here's the case 1 archive. This red dot means that the case or the tape that contains this case is not in online storage. In other words, it's not in the loader. Selecting the media list shows us the barcode or barcodes for the tape or tapes that we will need to restore this case. We've retrieved the tape that we need and we've put it in the mail slot and closed the door. Once we tell the software that the mail slot is closed, it will look at the contents of the mail slot and determine what to do. If it recognizes the tape, it will automatically put it into the first available slot. If it doesn't recognize the tape, it will mount the tape in the drive and determine if it's a brand new tape. If it's a brand new tape, it will automatically blank it or put the initial format on it. If it's a tape that it doesn't recognize but it does have data on it, it will mark the tape as foreign. Here we can see that it recognized the barcode and it put the tape into the first available slot, which was slot 4. Now if we go back to create restore job, you'll see that the case is now, or the tape is now online. I can go to restore here, and I can browse the contents of this tape. And if I needed to restore the whole case, I would select case 1. There is the option to rename the case as it comes back, or to relocate it to a different spot on your RAID storage. You can see that the system has automatically created a job. Here's the to be restored, and the schedule is immediate. In other words, as soon as we submit this job, it'll go ahead and do the restore. We could schedule this restore to run in the evening, but most of the time when you need some files, you need them immediately. Alright, so now we're back to the monitor job screen and we're watching the system perform the restore. The tapes themselves are indexed, so let's say the files you were interested in were at the very end of the tape. The system would fast forward the tape to the approximate location of the files that are requested in order to restore as quickly as possible. Again, in our particular demonstration, the case is very small, so the restore process actually takes a lot more time to move the tapes than it does to actually restore the data. At this point, the data has been restored and the loader is now taking the tape from the drive and putting it back in its slot. This concludes this demonstration.